frontier. We just dragooned you in by mistake. Please quickly introduce yourself. You're all from the University of Bristol. You do robotics. Peter.
Hi, afternoon. I'm Pete Winter, and I'm a sociologist of science and technology, and I'm working alongside computer scientists and engineers and ethicists, working alongside each other to kind of responsibly design a variety of different robots at Bristol Robotics Laboratory.
And you'll have already noticed something a bit odd. He's not a roboticist, he's a sociologist.
Yes.
And I think this is what's really interesting about the project that all of you are involved in. I'm going to come to Chris next.
Hi, my name's Chris. I also work at the Bristol Robotics Lab, University of Bristol. I'm an engineer, so I kind of look at building stuff and solving problems. At the moment, I work on this problem about how we show a robot is trustworthy. So if you imagine a bit like you've got a new dog, and the dog is in the sitting room, you've kind of left the room. My job is kind of how you show that the dog isn't going to eat the sofa when you're not in the room. But it's a robotic dog.
Matimba.
Hi, I'm Matimba. I'm a biologist/ethicist, and I work in the Robotics Lab and the Centre for Ethics in Medicine, and I'm actually looking at tiny, tiny, tiny robots that can find, target, and make decisions about a tumour cell, so making a much more intelligent cancer treatment.
And lastly...
Hello everybody, my name is Shyamli. I'm currently working as a research associate in human swarm interaction. So I bring in human robot interaction into the team, and I'm exploring the ethics as well as... Should I talk?
No, that's all right, just keep going. Just keep going.
So I mainly explore the human-robot interaction side of things, and we're currently on the go to conduct human-robot trials to see about how humans would trust robots, and we're also looking into like user-centric design, taking more feedback from humans and people from non-robotics backgrounds so that we can make better robotic systems for the future.
So, and I'm Roland, and I'm just here to ask the questions. You can keep the microphone. I'll grab it off you, because I want you, I don't want to work too hard if you don't mind. So if you've got questions, please throw them in at any point. I'm going to run up and down and get some exercise. I want to start just, I quite like this idea of would you trust a robot? So a simple robot would be, I don't know, maybe these guys will disagree with me, the dishwasher. You set it to some setting and it gets on and does it. Who trusts the dishwasher? Sometimes it overheats, I guess. Sometimes it goes wrong. What about these Roombas which go around? Who's got one of these robotic vacuum cleaners that you just put your feet up and it vacuums up all the dust on the carpet? Out of interest, because I don't. Good, I'm not alone. Nobody? Nobody. That's quite interesting. Would you trust a Roomba just to skip around while you just enjoy life? Was that a yes, I do, or
yes, I do.
You do? Okay, well,
the friend who has it.
Aha, and is it safe? Not safe, but
It's safe. Yes.
I'm so glad that you put your hand up. Okay. Which of you young children in here, well, not young, which of you children in here would like a robot that came in, or a set of robots even better, that came in and tidied up your room so that your parents didn't nag you? Oh, even the parents like this idea. Okay, parents, I want to know, which of you parents would trust the robot and trust your child actually to be doing it properly? You know. Would you? Well, but would you trust a robot to do the bed linen properly? Make it tidy. Would it just sweep? A smart robot. We've seen what artificial intelligence is doing at the moment. A smart robot would say, actually, I can get away with not tidying the room up. I'll just put it all under the bed, and Mum and Dad won't notice. So, parents, do you trust this robot?
Depends who programmed it.
Who said that? Who's programmed it? Okay. Who's going? So that's actually the question. So here's a programmer. Okay.
That'll be me.
Right. Yeah. I want a set of robots. I want 10 robots, which will go into the children's bedroom, work together.
Right.
Not go and knock over the things that the kids have been working on for the past week, but at the same time, Mum or Dad says, yeah, good job done.
Okay.
Challenge.
Can you tell me where all the things are in the room that I'm not supposed to break, or the robot's not supposed to break?
Lego stuff.
Lego stuff. Don't break the Lego models. Okay. Any other valuable
But you've
items?
got to still pick up all the little bits of Lego.
Okay. Can you tell me where the little bits of Lego are in that environment? Oh, okay.
On the floor.
So it's suddenly a lot harder than I thought it was going to be.
Swarms. Think
so
swarms.
this-
Don't break any valuable items like a piggy bank.
Okay. And will everybody in this room think that like the same things are valuable in that room? No. So this is kind of one of the problems I would have, is that everybody's room's different. So we call about this phrase called like a dynamic environment or an uncertain environment. So I don't know which of the Lego models are really valuable and which ones we're going to get broken up anyway. And I kind of don't know what the breakable stuff is. And that makes it really difficult to tell a robot that's, you know, avoid that, leave that, but this is all fine, you can tidy this stuff. And I think that's the real challenge that we have.
And I think for the kids, you thought, oh, great, I can just sit back. I don't have to do this because there's a machine that's going to do it for me. But it's actually harder for the machine to do it for you. I don't know, Pete.
Well,
This is the sociology bit. Would you?
I think sometimes it ties into the hype and the promise around these technologies. We kind of assume that these machines, or we equate these machines with higher expectations and a higher standard or sophistication of intelligence than humans, especially when we're working on a computer or a PC and it can do loads of calculations at one point in time. But actually, these technologies are actually really, really limited in what they can and cannot do. I don't know if you've actually seen the swarm robots in the swarm arena, but actually they're actually struggling. It's really, really hard for them to actually not bump into each other. And of course, as humans, since birth, we socialized in learning to not bump into each other. We know to keep our distance from other people, and there's a proximity, and that's through a process of socialization. But robots are not adept. They don't have that innate sense of socialization that humans do, and it's really, really hard for them to kind of keep their distance and their proximity when it comes to other robots not bumping into each other. And if you saw them, it was really, really difficult because they kept on bumping into each other. And so it's a question, it's one of the challenges of engineering to actually make sure that they keep their distance, they don't cause any harm, and then you limit the risk of actually what does this bumping mean in terms of other robots, but also when you throw humans into the mix and other types of materials and infrastructure as well. So it's about a case of reducing risk and harm.
And I think the point is, I think we really would like these labour-saving devices. This idea of the drones that will deliver packages or dinner. You could imagine a swarm of drones coming from the local pizza place, maybe, rather than a driver coming over. And there are all sorts of. The temptation is that these things are going to be there. So in a sense, I suppose what all of you are doing is balancing that sort of the temptation, the problems, and the truly ethical, the drone that starts spying on the back garden or something.
Yeah.
Okay, so far we've cleaned up a bedroom. Matimba, you want to actually clean up inside people's bodies, basically.
Well, I don't know if I'm saying I don't know in the phrasing.
Persuade these people that it's possible to let tiny robots into our bodies and trust them. So tell us what it is you're trying to do.
So we're looking at nanoscale robots or nanoparticles, and these aren't kind of traditional robots. I think when people think of robots most of the time, I've had things like R2-D2 and all these other things. But, yeah, exactly. But these are really, really tiny particles that can be made from metal, but they can also be organic. And when we're talking tiny, they're smaller than blood cells, and they would use the kind of inspiration from Swarm Robotics to be able to find a target a tumour cell. And the reason you want to target it is because at the moment chemotherapy is systemic, so it kills both healthy and cancer cells. So you want to be able to get just the cancer cells, and eventually make it so that it targets something that is very specific to an individual. So not just target the cancer cells, but target this person's cancer cell.
But you see, it does strike me, when you first told me about this, I thought, to be honest. And in a way, what you're talking about is a similar thing to cleaning up a bedroom, a machine that you let it go into the bedroom, but it's working blind inside a body. It's got to find the things that it must clean up, and it's got to avoid the things that it mustn't touch, I guess, is the interesting challenge. And so at this point, who trusts this robots or this set of robots to go in?
Get it to exit the body because you can't keep it there forever, surely. It must self-destruct.
Yeah.
I mean, that's a possibility actually. Self-destruction.
Like self-disintegration.
Yeah, and that's what we do with bacteria. Completely right? Like with synthetic bacteria, we can get them to self-destruct. It's almost like having a kill switch, so that they don't replicate at a certain point. And like other medicines, they will leave the body probably through things like sweat or urine or like, yeah.
I mean, but the interesting thing is, so my reaction was quite sort of, hang on a minute, in 100 years' time we can do this, I'll be very happy, maybe. But my reaction was, I don't know how many people would be with me thinking this is all a bit ahead of itself. No one want to comment? Okay, what was interesting is because you talk to a lot of people who actually are very interested in this.
Yeah, so I talked to doctors working with cancer patients, and I talked to cancer patients. I also talked to policymakers and to developers. And universally, I think everybody said that this is something that they'd want, but with certain safeguards in place. So.
But why do they want it?
Well, for a lot of the cancer patients, they said when you have something like cancer, it's a terrible experience for a lot of people.
It just changes your mindset.
Mm-hmm.
Absolutely, yeah.
Yeah.
And what are the questions? What sort of questions do you get from the cancer patients? What do they want to know that you can tell them about this kind of technology?
Similar to what people have already said here. People are like, well, how does it leave the body? That's a big one. And some people have said, well, what happens if it doesn't work for me? Which because this is specific for solid tumours. So some people with like blood cancers, they couldn't have it. So there were questions around that. Questions around toxicity, like what levels. Yeah, those were the. How expensive would it be?
Oh, well, that's always a good question.
Yeah, that was a question. So it's like, well, we'll have to ask NICE and the NHS, won't we? But I don't know.
But what about how you control them? I mean, because the acronym for your thing is TAS, which stands for
Trustworthy Autonomous Systems.
And the autonomous bit is the bit about robots that becomes interesting. These are things that you give them a task, and then they get on with it. So what's the control?
How would you control paracetamol?
By not taking it sometimes. No,
but
this is an interesting one because we have these antibody therapies for cancer, which are sort of a dumb version of this. They're molecules which will target their way to a tumour, you hope, but it's not any more smart than that. So this is an interesting point at where that control. I don't know. I mean, Chris, because you're the person who deals with the interface, because there's presumably you don't just let people won't want it just to get on with the job. They would like to be able to say, hang on, stop.
Yeah, no, I think this is something that happens in clinical trials. It's always an option to leave a clinical trial. And if it, as was said, you could have a self-destruct, like a way to neutralise.
One question that's not on here, but just my personal question.
Yeah.
Is how you would track it once it's in the body. So it's not necessarily whether it self-destructs or not. It's like, how do you track it once it's in? Yeah, it's doing a good job. That's brilliant. But it's that I think would give people nervousness.
Yeah.
Is it be going anywhere and doing anything?
You can add a biomarker to it, so like a tag, and you'd be able to watch like what it does.
I mean, apart from the size, what's the difference between what Matimba's talking about and the kinds of things that you're working with?
Well, I think there are questions around safety and matters around regulation, but I think in that case, it's a really good question. How do you track this type of technology in the body? And it ultimately depends on the kind of the organization, the quality of the interface and the connection, because, yeah, you can attach a biomarker to trace and track whether this robot is moving around the body and it's going to the right parts that you want it to be going into. But of course, it's another technology upon another technology, and another technology upon another technology is always testing upon testing upon testing. And this biomarker, this tracing mechanism could have a fault in itself, or it could be scrambled, it can be hacked into as well by some kind of nefarious agency. I won't mention Putin or anything like that. Yeah, and so there are multiple safeguards and things that we need to consider, but there is a question around the quality of the interface, and if you have to kind of anticipate that the biomarker or the tracking mechanism will be faulty, because we're dealing with a very sophisticated, I mean, we talk about these machines as being sophisticated. Well, there's nothing more sophisticated than this machine, you know. So this is our bodies, right? So it's a case of having to ensure that this is an interface there and we're able to track it. And what happens if it fails, that there is a safeguard in place to make sure that's something we're able to kind of recover it or repair it. So we're getting into these really sophisticated questions around notions of technology that repairs itself. And this is where kind of people with the soft robots comes into play, where they're talking about materials that replenish themselves and self-heal. So not only are they conducting a particular task, but if they do have a fault or they do break down, they're able to replenish themselves as well. And that's a new wave of robotics that's happening at the moment. And of course, that kind of makes sense as well, because this comes at a massive, massive cost to you and the taxpayer as well, and the NHS as well. And there is a cost case, an economic case that needs to be built into the development of these technologies, where if they do break down, then it makes sense to have something that does replenish itself, because then no one's ultimately paying for it as well. Because these are really, they take a long, long time to be used and tested and implemented into real-day situations. But like anything, things break down. The more sophisticated technology it is, it breaks down.
Well, with the sophistication, Chris, I was quite interested in this, because presumably the more sophisticated the thing's going to be, the more complicated it is in terms of you just got to have a bigger chip there, and it's got to be able to handle more instruction sets. And then if we're also going to have it so that it interacts with the people outside, you say, no, turn left, not turn right. The moment you do that, that is also opening a window whereby hackers can get in there and start messing around with it. This is a ballooning problem, isn't it, in terms of computing power?
Yeah, it's fair. It's like the more moving parts there are in this, the more chances are that something's going to fail. That's definitely true. I thought there was a point that Pete made, which is quite interesting, saying we're the most sophisticated, at least that we know of. It's really interesting because obviously autonomous systems, robotics, we're kind of thinking is a new technology. And there's a temptation when we get new technologies, we kind of think everything's new, we've never seen this before. But if we think about, say, we trustworthy autonomous systems, we've all experienced autonomous systems all the time. Every time you go on a plane, you have a pilot piloting the plane. The difference is it's a robot, it's not a robot, it's a human. But we have a co-pilot. You know, that's one of the ways we get around the fact that humans are fallible, therefore we'll put a co-pilot in, therefore we'll put lots of big warning lights up, we'll have loads of things built in, safety features. I think that's probably what we're going to see in robotics. So the sort of things that Matimba's talking about, it's not a case of you just let it go and hope it all works correctly. You build in safety features through your design that ensures that actually, even if it doesn't work the way you expect it to, there's kind of a fallback plan.
Yeah. See, for me, it's partly that we've learned to trust things so much because of our own upbringing, basically, the fact that we've been socialised. I was just wondering, how anyone in here who's under 8 years old, could you just stand up? Under 9? Under 9? Under 10? Go on, stand up, yep, keep. I just want you parents to understand.
I'm 14 and he's 13.
Okay, but how sophisticated? If you can give very simple instructions like go to bed to your children, or breakfast time. Is that a good one? Do you like breakfast time? No, you do, right?
I like breakfast time.
And you were saying earlier how people you can walk down the school corridor without actually bumping into each other, can't you? Can you really?
I'm still in.
Did anyone type in the instructions? No? Do you know how not to bump into people in the corridor? I think, and that's the point. I think actually we, in a sense, you were talking about the hype earlier, we so project what we think is simple in life onto what machines can do, and then they get it wrong and we think the machines are stupid. And it's actually that even, very small children are incredibly sophisticated in terms of doing this. And I don't know if that's part of the trust thing. I don't know who wants to take that.
I think our role, though, in the project is to question the origin of these promises and these hypes. And I think sometimes by calling the project, and it's a process of learning, you see. When this project began, trustworthy autonomous systems, over time we've realized that probably autonomous is not the right word to be used. But at the beginning, it was a kind of almost a marketing term, and you get people like Elon Musk talking about autonomous vehicles and self-driving. These marketing terms, these over-promising, it's really not helping public perception in the way we kind of create things. And I think what we've happened over the course of the project, it's safer to kind of like talk about these machines in terms of like highly automated, because we talk about smartphones, and yeah, there's a lot of kind of autonomous systems and autonomous interactions that happen with your smartphone, and we've accepted this technology without much pushback from society. But the longer that these smartphones and this technology, which we've accepted without questioning, have become more integrated in society, more questions have started to raise. We're actually learning about this technology, especially when it comes to like social media harm and things like that, and the risks to kids. And no one really was considering this at the beginning of smartphone technology and using these applications on the phone. But it's a process of learning, and I think autonomous probably isn't the best way, because we want to keep humans in the loop to make sure that we have control over them. And now even and the discourse, we call it the discourse, is changing, where people like Elon Musk and technology companies are talking about these machines in terms of like highly automated rather than autonomous.
But I guess the autonomy bit is partly that we don't want to have to supervise them. If it's cleaning up a room, you don't want to be there. And again, this goes back to the children. You don't say to the child, move your left leg, move your right leg, move your left leg. They get on with it.
Well, yeah,
and
to a point.
You want the robots to do the same.
Yeah. And I think with what Pete was saying, I think language is tricky, isn't it? There are some things that you're like, oh, actually, from a technological point of view, it's not at that stage where it's fully autonomous. But then from the transparency point of view, if that's what you're working towards, then and you stop saying it, it's almost like you're hiding something.
And even the Roomba, though, okay, perceptually, we see it cleaning up and it's behaving autonomously, but what happens if a sock gets stuck in the wheel? Or actually, hang on, who actually has to empty the tray? Well, we have to empty it, and we have to clean it, we have to charge it and things like that. So it's not operating autonomously, it's the marketing term that's selling it as an autonomous thing, but actually there's still a lot of human interaction, human involvement in actually the maintenance of the actual robot.
Now, I just want to take a digression, because there's another thing which has been going on this week. Shiny, talk us through this. You've, as well as just coming here and having the exhibit, you've been talking to some of the schools around here about your work. Just quickly talk us through the challenges you gave to the...
Hello, everybody. So as part of my role being a research associate in human-robot interaction, we also wanted to know opinions from the public, especially from the children. So we decided to give challenges to kids, and we went around schools in Swindon. So we went to a primary school, and we asked kids of year 4 and 5 to draw a robot from their imagination, what they would like a robot to look like. and what tasks would it like to do, something useful to humanity. So people came up with all kinds of robots. Like kids came up with all kinds of robots, from an artist robot to a gardener robot to an all-in-one medical robot. And
come up here and let's just talk through some of them.
Yeah.
I mean, I love this one here.
Yeah.
This is an ocean cleaner.
So these were ones made by the older kids, year 8, 9. So these we had given them again the task of, you can either create a video, write an essay, or create a poster on a robot and tell us more about its features and what it does, and describe in sentences what it does. And we were really mesmerized by the ideas that children came up with. So one is Aqua Pure. It's more like a submarine-like robot, and the main purpose is to ensure that oceans, like Indian and North Pacific oceans, stay clean and habitat-friendly. And then here we have a cancer detector. So more like the sensor detector that you would see in the airports, where a person would walk through and it would detect any metal item or any undetectables. Similarly, you can simply just walk through and it would detect cancer. That was the idea from a team, and this was really cool. And then we have an underwater robot, and then we have a gardener robot, and then we have a chopper. We also had one of the ideas from a child, and it was named as Bio Drone. So we had taken them through the different kinds of robots that already exist, and then we wanted them to think out of the box, that not all robots look like humans. There are still robots out there which are very differently shaped, with different activities and different tasks.
That's me, I think.
Yeah, sorry. So the bio drone, I remember that it would do agricultural applications and anything to do with biology. So environment, human, agriculture, wildlife. And then this is another robot which looks like a humanoid. And then they've labeled it. It would learn from people. And it has different functionalities, and that's what the child has labeled. So it's been very interesting to see their ideas, and we take inspiration from the ideas of the future generations to help us make the robots better. So the idea behind human-robot interaction is to involve humans in the design process from the beginning. So for example, if only engineers were there in the team, and if we're making a robot and just putting it out in the market and just waiting for people to accept them on its own, it's not going to work that way. The users have to find it friendly, and for them, it should be comfortable for them to use. So if you're designing a medical robot, from the beginning of the process itself, we would try to involve post-surgical patients and doctors to ask them, what do you actually want out of a robot? And then start designing the robots accordingly. And which is why the field of robotics is also very wholesome. Like, we're including ethicists and sociologists, because we just don't want the engineer perspective alone. We want like a wholesome perspective design. And the intention behind conducting these competitions was also to know the thoughts in the young minds and what they perceive robots as, and how we can make it more closer to reality.
But when you ask the public, don't they just ask, well, not just ask, and not always, but they quite likely to ask you for completely impossible things. Let's say a submarine that's going to clean up the ocean. I mean,
I understand.
How do you work with that inspiration?
Well, maybe I think you guys can also help me answer this question.
Take that one.
I think so. Yes, a child came to us talking about an all-in-one medical robot. Like, it has a pharmacy inside the robot. It has like many injections and loads of medicines inside the robot. So, maybe an all-in-one is not always possible. But then, so that is where like the technical challenges of building a robot comes in, and the personalization factor. Like Chris was talking about, different people have different objectives and different rooms in mind. So, do you want to talk about the challenges behind, building robots?
Yeah. I mean, there's so many technical challenges in different ways as well. Like, I think one of the things I thought of straight away about this cancer detector, I was just like, well, there's so many cancers we don't know how to detect yet, and we can't detect them at a very, very early stage. So how are we going to be able to program this into a robot? And then the other thing was, if it's a detector in the airport and someone's just walking through, I mean, this is quite traumatic news to get just before you get onto a flight. So I don't think it's a.
I was wondering about the privacy issues with one like that, because presumably there are things which are not appropriate in some places and not in others.
Yeah, there's that as well. The amount of data that you need to be able to make these things and be able to collect the data as well, you need a sufficient amount. And it's not always that easy to be able to get that for research purposes.
I would like to give it a design thinking perspective to it. So we would get the initial ideas and the inspiration from the public, and then we would keep iterating the idea so as, you know, we meet their expectations in a way, but also looking into the practical challenges of making it. So we would like keep iterating the model till we find a realistic solution meeting both parties. So that is how design thinking would eventually work.
I mean, the Elon Musk self-driving car is, I think, a classic one, because in a sense it's, the idea is a very attractive one. But I guess the reliability, the trustworthiness, will it stop at the right point? Does it recognise pedestrians? What happens if the rival company's car tries to overtake? Or, I don't know. I guess that there's...
The challenge ultimately is we don't know what we don't know.
Yes.
So there are limitations to our knowledge at the moment.
And are you finding out what it is we don't know and how to... That's, I suppose, what I'm wondering.
So the best that we can do is use specific methodologies to use anticipatory methods, which is this kind of like asking foresight questions about trying to do our best to anticipate, you know, risk scenarios. And we can do a really, really good job at it, but there are still going to be holes because we don't know everything. And we can't, and our behavior is so sporadic and unpredictable, especially when you deploy these systems. And great, we've trained it to, for example, avoid a pedestrian crossing the road, but now, what's complicating things, for example, is this little thing called climate change. You know, we're not anticipating, so we've kind of built a self-driving vehicle to accommodate, you know, normal behavior, normal weather patterns. But as we going further into the future, it's becoming more and more difficult to anticipate and predict behavioral how the weather performs or behaves. So. These kind of issues in terms of like how much rain and flooding, these kind of issues creep into the performance and the safetiness of vehicles and technologies as well. So this is another thing that we have to consider around the unpredictability of these systems as well. It's not just the unpredictability of humans, but yeah.
Oh, sorry, yes, please, make my life easy.
So I just wondered what you thought with regards to if robots are doing more and more and humans are doing less and less, what does that mean, in your opinion, about the future of human intelligence?
Do you feel humans are doing less and less? Like, do you feel like you're doing less and less in your day? Or?
Well, like, not so much with the amazing work you're doing with regards to...
No, it's just a question.
More your example about robots that clean rooms so you don't have to. That sort of...
the mundane kind of...
The mundane things that really just, I don't know, kind of like what you were saying, no one could foresee the effect that smartphones were going to have on mental health. When it first came out, everyone was going, oh, this is incredible.
Yeah.
Like, how is it going to affect the human brain 10, 20, 30 years away if everyone has stopped being able to do basic things for themselves?
I mean, I think there's with mobile phones, the question of dependency is actually quite an interesting one. When you know what it's like when you're in a strange city and your mobile phone runs out of charge and you can't look at the map anymore.
It's one of the most important questions everyone is trying to deal with. What you're talking about really is this concept of over-reliance. And then when you over-rely on something, what happens? We become de-skilled. And that can be anything. It can be de-skilled in cleaning your room to becoming de-skilled in carrying out a diagnosis. or de-skilled in driving a car or whatever, because we're just giving too much authority to the machine. So rules and kind of standards and more accountability needs to occur with companies, organizations. It has to happen on a global geopolitical level to make sure that there's thresholds in place. Because you're right, I can't remember, I think maybe some of the kids in the room will probably know, but there is a Disney cartoon where this future scenario takes place. I think it is the one with the cleaning robot. What's it?
Wally.
Is it Wally?
Yeah.
You said Wally.
Yeah,
so that is the
Yeah.
future.
I think about that film a lot.
Yeah, so
Yeah.
that is the future that happens, because I remember in space everyone's just quite big, aren't they? Because they don't have to do anything for themselves anymore, and that could play out.
Bring that problem into your work.
Yeah, no, I think this is an issue, and I think that one thing that we need to do as researchers is not just creating work without consultation from other people. I think, I know that we've started to consult people now, but just truly co-creating work, so from the very beginning, before we have a research question, like doing that with members of the public and other people to make sure that we're actually doing something that people want, and rather than doing something because we think it's cool.
But like with everything, with especially with the post office scandal as well, it all comes down to, well, money, but power as well. So there needs to be some type of accountability for companies and organisations to make sure that they don't do this, and there's a threshold. Yeah, it's great to delegate tasks to machines, especially in a healthcare setting, where there's a kind of a shortage of staff, so there needs to be some kind of assist to help them kind of alleviate backlog and workloads and things like that. That's a really good example of the application. But then, what happens if that?
That's super reactive, though.
Yeah.
Like, because in a healthcare setting, like, people are much more vulnerable.
Yeah.
Just because you're like, there's a shortage of staff, so we're going to replace this.
Yeah.
You can't do that. You need
Yeah.
to first really think about the situation.
Yeah, absolutely.
And think about how that's going to impact someone.
Yeah.
Like the care, not just physically, psychologically as
Yeah.
well.
And that's exactly what needs to happen, because these technologies are essentially being developed to, automate certain tasks to alleviate workload, but there's a threshold to not go that far to the point where they're replacing humans and expertise, and hopefully a more of a hybrid practice where expertise exists and coexists alongside these technologies. It's difficult to do.
Years ago, I was at Carnegie Mellon University in the States, which is one of the great robotics places in the world. And one of the guys I'd met there had done this fantastic guide robot for the museum just across the road, and it would welcome the children coming in, and it would show them around the room, and at the end of the day, it knew exactly where to go and plug itself in, so it'd be recharged in the next morning. And it was a lovely idea. And I went to the museum a bit later, and I said, "Oh, is that robot here?" "It's broken." Well, yes. First of all, it got in the way all the time. It didn't do what it was supposed to do. The kids spent more time looking at the robot than going and looking at the amazing dinosaur bones and everything. And it needed endless maintenance. And I think there's this comes back to the relationship between us and the machine, and also the expectation.
Yeah.
I think something else is, it's very easy to think robots can do this, robots can do that.
Yeah.
But actually, us as humans, we are social, we do need that physical
Absolutely.
contact. So the idea in New Zealand of the restaurants with the robot waitresses absolutely horrifies me. Part of going into a restaurant is having that human contact.
Yeah.
I mean, because one of you works with those little
Dots.
Yeah, I mean these are sort of robots you get in warehouses and stuff.
Yeah.
And so I'm quite interested in that one. The robot is doing the drudge work, but actually, where do the humans fit in after a while? Is that something you look at? I mean, these are the big warehouses where they can just I guess the Amazons and so on, where they can just collect things. Where do what's left of the humans?
It comes down to, and this is why the rules it comes down to power. Unfortunately, if there's a business case, if Amazon makes a business case and saying, look, we can, by automating the logistics of our warehouse, where customers get their packages, the right package, and the package is speedily delivered, and we're reducing health and safety incidents, because obviously there's a lot of risks in working in warehouses. You know, things can drop on you, so it's quite a dangerous place to work in. And if you can save lives, the business case will be to completely replace the workforce. Now, there needs to be thresholds in saying, well, okay, yeah, we can automate to a point, and this is the same with the healthcare setting, but also other types of domains as well. We still need those human interactions. Still need to be, there needs to be oversight mechanisms, and to make sure that companies don't have the power to automate things, because, yeah, things break down as well, and we need to kind of make sure that there are interactions and maintenance and tinkering that goes on to ensure that they're safe and they're doing the things that they're supposed to be doing as well, you know. So it's a question of balance that needs to occur.
I think each time a new kind of technology was introduced, like the calculator came in, everybody said calculator would be a disaster. The internet came in, the computers came in, the smartphones came in, and then now the robots are coming in. So I think it is a lot dependent on the user, and again, you know, the ethical regulations behind the company and all of that. So I'd like to believe that robots are here to augment humans, to help humans. For example, children with special needs, or you know, anybody who needs assistance around the house. That in those kind of cases, the robots are actually helping to enhance the human capability and to help them do their tasks even more independently, right? So if you're talking about a warehouse context, or even a medical surgery context, it might not have to be fully autonomous. It could be semi-autonomous, where you know, mundane tasks of the human, a lot of it is done by the robot, and the human can use their creativity to do much more productive tasks. And in the end, it becomes a human-robot collaboration, which ends up doing even more efficient work. So I think if you see it that way,
that's the ideal.
Yeah,
that's what we want to get to. Yeah.
I think kind of expanding on that.
Yeah.
I agree with you. I wouldn't want to be served by a robot at a restaurant because I need that human interaction.
Yes.
But I saw a video clip of a restaurant somewhere in Japan, I can't remember where it was, where they had robots doing the serving, but the robots were being controlled remotely by people who were bedbound.
Exactly.
So it was giving these people who were completely bedbound a job.
Yes.
Which they wouldn't normally have.
Exactly.
Amazing expansion of opportunity.
Thank you so much for So thank you so much for saying that example. That's exactly what I had in mind. So as some jobs do lose along the track, new jobs are being created as well. So that is what has been happening over the ages and over all of these years. So if you see it that way.
But I think your worry was that people might get squeezed. Some people might get squeezed out in this.
I guess people would have to upskill.
The maps, isn't it? And I don't know, I think a lot of humans would err towards like laziness if that option was available. So although there's these extremes where it's amazing, it's hard to make sure that it's just being like all the ethical principles you guys are working on, keeping that at the forefront, isn't it? So that
absolutely.
Humans are becoming de-skilled in so many areas already.
I think the answer is upskilling.
I love your optimism. What I do want to know, very big. So you did this schools exercise. By the way, there's this panel, but there are some more panels near the entrance to the whole exhibit, the festival, which is worth going to.
What about, you mean like academy?
Yeah, just at the front door. But what was I going to say now? Yes. So you've done this in Swindon. Have you done this in other areas?
No, now only in Swindon.
So we're the best so far in Swindon. I mean, you felt energized, did you, by
very
meeting
much.
The kids?
I loved talking to the kids. Like, I was very mind blown by what all ideas they have, things that we've never thought about. So that's great.
I just wanted to finish briefly with, because a lot of what we're talking about is we're saying, oh, what will it be like in the future? But I'd like to calibrate sort of where we are and where we're going. And if I can start with you, Matimba. So your stuff sounds mind-blowing. But I imagine that you know, the stuff you're thinking about will be in 10 years or 20 years' time, but I might be wrong. What are the little robots like at the moment that might resemble what you're talking about?
Yeah. I guess where we are, like, there's so many things, isn't there? Like, so in terms of our population, we're like a growing elderly population, and with that comes some of these like diseases like cancer, Alzheimer's, and they're likely to increase in the next couple of years. And then when it comes to the technology, so nanotechnology has been around for a really long time, actually. Like, so nanoparticles, the Romans used them in cosmetics, and this idea of this like tiny world was talked about by the physicist Richard Feynman back in the 60s. So it's not a new idea to use like kind of these like molecular machines. So in terms of like lab work and looking at kind of these tiny micro particles, we're not in human trials yet at all, but animal models and bench work and computational models were definitely there.
I mean, so there are actual small robots
but not
of some
to
kind,
the swarm
or
level that I'm looking at, but yeah, to where you can control movement and emotion, and with it, yeah, at that level, that is like there, but not.
Do they even blow your mind when you see what the engineers are up to?
Well, yeah, it depends. So because some of this work isn't just engineers, it's also the biologists and the chemists. Yeah? So we can't just blame the engineers for everything. But yeah, I think when you think about it on the bigger scale, it's always like, wow. But I think when you're in it every day, you just don't absorb it as much. But yeah, in the next, I don't know, 10, 20 years, I think we just need to really focus on what we want to be as a society and what we want the future to be as well. How we want to live and what we would be happy with, what are our values. I think that's what should dictate innovation.
Chris, I mean, because the big theme is not just robots, but swarm robots. So I you know, how many swarms are? I've seen those amazing drone displays, and they're fantastic instead of fireworks.
We cheat a little bit on those because they're all like centralised control that kind of works with a lot of them. So they're not like a pure proper swarm.
Oh right, they're all just centrally controlled and all being choreographed.
Yeah, they've got some local control, but mostly centralised. How far away are we from swarms in the real world? Good question. This is going to sound really silly. The biggest problem we have is power. And there's loads of like really basic things. So you think about a robot and all these clever things they can do. Quite often it comes down to we need a bigger battery because it needs to last longer if we want to do anything useful in the world. You know, it needs to be able to lift things. So if you go and play with the drones that we've got, they can't really lift anything. You know, they're as light as they can possibly get because that's the limit of the technology, the motors and everything else that goes with it. So there's this kind of tension. On the one hand, we're trying to push forward this intelligence and getting swarms out there. There's all sorts of other limitations which are just more practical. It's things like how do you make a bigger battery? How do you get a motor that's a little bit stronger and also lightweight? And there's all that technology still needs to come quite a long way before you'd realistically kind of deploy at least swarms in kind of like the robotic swarm that we're talking about in the world, at least for longer periods of time.
But your swarms would be robots talking to each other, but also, I guess, with light sensors and cameras to see where they are.
So a true swarm robot is a bit like a bee. It's what we call behavioural controllers. So it's all basically reactionary. It's kind of responding to the world around it and to the other members of the swarm. They don't have intelligence in the sense that we do, as in they can kind of look at the overall picture and see what's going on. They're just responding locally. That's what kind of we think of when we think about a swarm. And yeah, we're quite a long way from being able to put this in the real world, I think, en masse anyway.
In that sense, Pete, you know, you're the sociologist, and you're talking to people about things that don't exist, or you know, how do you get your information when you go and do surveys and so on?
I think it's promissory in the sense, I think we have to have a dose of reality, and we always working alongside the engineers and computer scientists, we kind of, we're kind of pragmatic in the sense that this is why it's important for computer scientists and engineers, and we're part of a multidisciplinary team. And sometimes I think we bring a dose of reality where we consider the wider socio-ethical implications, where we're worried about companies. We're worried about people who make decisions and how much power and authority they have. We're worried about money and how money is spent. The case with drones, a great example. I mean, for example, delivery drones can deliver medical supplies, you know, to remote islands, to remote locations, war-torn locations, which is fantastic, immediate medical supplies. But actually, in reality, that's really, really difficult because they require a lot of energy, and that energy just dissipates, really goes really, really quickly. So then the question comes in of like, well, how do you actually provide a robust and long life-serving battery supply? And actually that's really, really difficult because you've got to integrate it into the system. And then you've got to actually, where do those materials, this kind of zinc and these minerals come from? Well, you've got to mine them. That costs a lot of money. So these, and then what kind of influence, what implications does that have on the countries that are mining these raw materials? Can we have access to these raw materials? You know, for example, you know, China have a monopoly over like zinc and these kind of minerals, and that might be a problem in the future if there's more geopolitical tension between the countries. So it goes on and on and on. And I think that what we bring to the picture is that these are complicated technologies with complicated issues, and there are no neat engineering solutions. There are resolutions, and what we mean by resolutions is that these technologies and their applicability are resolved by politics, by people who say yes and no, and they're influenced by social, cultural, epistemological, knowledge-based kind of issues, organizational issues and things like that. So we kind of influence, we bring all this kind of wider dynamics into the development of these shaping of these technologies, because they're not just technological things, they're being shaped by a lot of social, ethical and cultural factors as well.
So you never go into the robot labs and say, "Oi, what are you doing?"
Yeah, no, absolutely. We do, and we understand it. But actually, you know, the technologies even now are actually such a very fetal, very early developmental stage. A lot of it is just simulation based, you know, just computer graphics. So this is why we've got to check ourselves when we talk about these technologies and not get sucked into the promise and the hype, because they pretty much do exist as simulations. And the ones that do exist, like the self-driving cars, they're actually being tested. They're still being tested on the roads as well. And there's a lot of issues if you just type in self-driving cars. I mean, San Francisco at the moment, there's a lot of pushback from, they're one of the test beds at the moment. And they're causing a lot of issues when it comes to kind of interacting with fire engines and things, because someone didn't think about, well, what happens if you get a fire engine, two fire engines, and then a person in the middle, when it just stops, the car just stops, or it just runs over the person because it can't navigate between the two. Things we don't know. We don't know what we don't know.
I'd just like to big up Bristol University, because, is it Gray Walter? What's his name? Walter Gray? He back in the 50s. Come on, you must know your history.
We don't know what
we
don't know.
Small robot.
We don't know everything.
I was like, oh, sorry, unfortunately, I wasn't here in the 50s.
The world's original swarm robots. You can find them. There are some fantastic old news clips on YouTube and so on.
Right, okay.
A guy called Walter Gray, he just made these little robots. They called them tortoises, I think, 'cause that's what they looked like. They had wheels. They're little tricycle things, and they had a light sensor on the front. And he could do the same kinds of things. Please go and play with the toys over there, because they are brilliant. But he showed how if one had a light on the back and the other had a sensor on the front, they would follow each other. And that was back in the 50s. I mean, and that was Bristol University.
Pioneers.
Yeah.
Pioneers.
Okay, so can we just finish with some optimism?
Thank you.
Go on. Tell us, this is the future we want. Yeah?
So, yeah, thank you for quoting me as optimistic. Yeah, I would definitely be like to be optimistic about the future. So I think it's about taking our viewpoint and stand towards technology, and also, you know, seeing them as robots are still developing. and robots still need humans' help to, reach the fullest potential that they aim to be in the future. And I still like to say that I believe robots are here to augment and enhance human capabilities and help shape a better future. So thank you so much for all of your patience and all of your encouragement. Thank you so much for listening to all of us today.
Thank you.
And we have a website if you want to get in contact with us as well. I think all of our contact details are on there. We're the Trustworthy Autonomous Systems node in functionality at Bristol University.
Or just see us at the stalls.
Yeah, all that as well.
We're approachable.
Yeah.
Okay, thanks very much for coming.
All right.
Okay.
Thank you.
So thanks, thank you.